people. So Nicolas, the founder of the BionicoHand project.
Merci, Catherine. Bonjour, my name is Nicolas Huchet. I'm the founder of My Human Kit. It's an association. Well, it's a fact, human is good in creating technology. And today we can also say that human is good in making sense, giving sense to technology. We can see that today. There is still a bit of work, but I think we're on the right path. The next step is how to use technology to educate people, how to make the technology available, and how to empower people with technology. This is the next step of the human being. Well, my story started in 2002. I had an accident, and I learned how to use this 90-70 technology. You can call this a bionic arm, but the real name is myoelectric hand. I live with it every day. It's not my best friend. It's not my, as we say in French, mon doudou, you know. But let's say it's my body mate, because from the 8 a.m. to late at night sometimes, it's my tool, you know, and I can do everything with that. This is 21st century technology. Actually, I just forgot something very important. The hand is separated in two parts. There is the electrical hand with a motor inside, and the other part is called the socket. Inside the socket there is a battery and there is electrodes that we can call muscle sensors. These muscle sensors, and this is important to remember, they get the muscle contraction of the body and converts it into electricity. This electricity will control the motor. So you can see here that right now I'm contracting the top of my arm, and now I'm contracting the bottom of my arm. By doing this, I have two separate movements, and I can control the hand and think that get a normal life. This is how it works, and the socket is very important because the socket is like the shoe, is where you are feeling comfortable. And if you're comfortable within the socket, the shoe, then you want to wear it. But it looks like technology have a lot focused on the hand itself. So today, 21st century technology, there is hands with, we can call polydigital, because they can move each fingers independently with actuators, a lot of things connected to a smartphone, and there is even more hands on the market. But these hands are very expensive. They cost an arm from 20,000, which is the first joke, 20,000 to 100,000 euros, dollars. So we can say that between 90 to 99% of the people just cannot have access to it. So that's the problem. Then 3 years ago, I discovered Fab Labs. I didn't know what was that. And when I saw a 3D printer for the first time, of course my question was, is it possible to make a hand with that? And they seemed really interested in my case. When they saw my bionic arm, you know, they said, you know, usually people are a bit sorry about it. So they were like, wow, it's great. I was in the geek area. And we went on Thingiverse, which is a site with a lot of 3D designs, open source. I didn't know what was Thingiverse. You know, you can download and 3D print a lot of things. And we found a hand, an open source robotic hand. And back home, after I met these people, I found that idea very crazy. I went back home and watched that video. So you can see someone controlling the hand with the keyboard, and I just thought, okay, if he can control the hand with the keyboard, we can probably control the hand with the muscle sensors. And we started to work together with the Fab Lab in Rennes, where I live. And they said to me, yeah, we will help you to make your own hand, but only if you share everything on internet for other people. So it was double sense to me, first to fix my own body, and secondly, to help other people. So we went to my friend's garage, and this is how I learned. So actually, I was with my real hand and my bionic arm making a hand made of plastic. So I was dealing with 3 hands at the same time. Really interesting. I couldn't make a mistake because I was going to wear this hand. But it was really interesting, the psychological effect on me, you know, feeling that I'm fixing my body. And then we went to Roma, and this is the InMove robot, who was here actually 2 weeks ago. It's an open source robot that you can download the parts and make a robot if you want. So we made the hand, and you can see on that picture that it's the same principle as a Myo hand. There is a hand, motors, and sensors you can see on my arm. And everything is open source. It's an Arduino-based electronic board. It's open source 3D design of the hand. The cost is about 300 euros, okay? But it's just a proof of concept right now. But the fact of acting on myself as an amputee and trying to fix my body and becoming an expert in bionic hands changed the way I was looking at my disability. So I will very insist on how it works, because a lot of people are really interested about that. Everybody is okay with that? Don't ask me after the talk how the hand works, okay? Thank you. So, now, we've been working on that project for 3 years. We want to create an affordable, easy to make, easy to fix open source bionic hand. And I realized there is a lot of projects like this, like mine on the planet. There is a lot of projects. We started to make the InMove hand, as you saw. Today, this $300 hand is at Musée de l'Homme in Paris. And there is other projects, like in Bristol, there is a company called Open Bionics, and they make 3D printed hands as well. And I'm going to show you that 2015 technology about bionic hands. So everything is 3D printed, the hand and the socket. Yeah, just give me the... And I just plug the sensors on the electrodes, and just plug it into the battery. So I'm just doing the same as I'm doing here with this hand, with my doo-doo. And the cool thing about this, that this hand costs about 1,000, and everything is open source. And everything is 3D printed. So the next step would be, how cool are going to be the next robotic hands, bionic hands? But I think there is a huge step before to make very cheap and robust bionic hands. You know, it must be very robust. It's like if you have a car and you cannot drive it because it's very fragile. So there is a focus we want to make on the socket, that part. Because if you 3D print sockets for bionic hands, you can also 3D print orthesis if you break your arm. And today, I'm just looking for an expert, someone who could advise us about biomaterials, bio 3D printed materials that can be comfortable, strong enough, and with no aggression to the skin for the people. Because we will need a 3D printer as well. And I'm asking you today, if you know about this topic, what would you advise us? Then we thought, okay, what are we going to make? Are we going to focus on the hand? And we decided with my human kit to focus on disability generally. And this is how now we have 5 projects we are going to work on. It's about open source solutions for disability. And we are going to make the BionicoHand an open source wheelchair that already exists, a sonar glove for blind people, audio prosthesis for people with hearing loss, and an artistic project for people who have hearing loss to see sounds. This is my human kit. If you have any advices, if you want to help us, you can. And I'm open to any questions. If I can make myself even more clear about how the hand works, because I'm not going to repeat it after. We have 4 minutes left. You can ask questions, or I can keep on telling my life if you want. It's okay? Okay. Anything to say? Should I maybe go? Yeah? Any questions? Yeah? Well, at some point, yeah, we would be able to, that's my dream is to play piano. And quickly I realized that if we make a hand with 5 actuators to move each fingers, then the hand is going to be heavy. It's going to be very expensive. So my focus is to make something that can help people. And also the first reason why people don't use these super cool Terminator bionic hands is because they are very heavy. That's the main problem. And as a user, I want to precise to the engineers that you really must work with the people, because the technology in terms of bionic hands is very interesting, but I don't think it's a response to what people need. People just need a tool to be able to live as they used to live before. But instead of that, the technology makes something very polydigital, and you don't really need to do that or that. I mean, you need sometimes, but just sometimes, you know. So it's a focus, but I think it's a long way before. We just want to make a 3 degrees of freedom hand, customizable. 2 more minutes. I'm telling you again, I'm not going to repeat. So if you want to know, ask now. Actually, you can see that this hand has several movements. If it's going to work. Well, she's a bit shy. But I can move each fingers like this and like that. It's using a program that can switch from one to the other one. But then the next step is going to be multi-pattern control. It's a way you have 4 or 5 electrodes that will make a pattern, and each pattern will correspond to a movement.
Nicolas.
Yeah.
That's very cool, but you still have cables connected to some batteries.
Cables? I don't see any cables anywhere. Yes. Yeah.
So what's the next step?
Next step, of course.
Energy generation or battery?
Yeah, energy as well. Yeah, energy. Energy. Yeah, integrated. This is the. You can see that product. Everything is inside. Yeah, definitely. Yeah, we want to get rid of all of these things. Yeah. So muscle sensors directly here, and now that's on the market. Open source electrodes without wires, and battery integrated inside. Yeah. We also want to work on the feedback, how to feel what you touch, and how to make how to 3D print sockets. This is what we want to do. This is 2016 focus. 3D print sockets. And yeah, well, thank you very much.